the ducting that's in the attic. A lot of the times what we've seen is they run flexible insulated ducting, the kind of the same stuff you'd see on an air exchanger that you see in the basement, the lines that come in from outside. When you're running heating in the wintertime, where do the mice want to be? They want to be next to the warm ducts. So what do? They chew holes in the plastic and they bury their young and their babies and everything inside the lining of the ductwork. And then what happens is Mrs. Jones calls for a service call and can't figure out why there's no airflow. And it's because the mice chewed a big giant hole in her ductwork in the attic. So yeah, and to follow up to that without taking too much time, like I said, if you go to our website, there's a blog post there about why you should not put a heat pump in an attic, and it will kind of break down all of the reasons that it's not a good idea.
Okay, and that was kind of my understanding with it too. I guess I didn't know if you installed them or not because I haven't read that post, but yeah, and you answered the follow-up question was the increased condensation that would be in the attic. Is there anything specific that you would need to do in order to eliminate?
Well,
you actually.
Yeah, well, normally what we've seen is anyone that's in Halifax doing it, because you know, you guys are real estate agents, so as you go on in real estate, you kind of get an understanding of the building envelope and how it works. So when you drill a hole through your attic through the drywall, you end up breaking the vapor barrier through the attic. And what we've seen is we've had customers call and say, I have water coming around the vents from the heat pump that's in the attic.
Yes.
And the reason why is because whoever installed it, when they cut the hole through the drywall and cut the hole through the vapor barrier, they didn't seal the vapor barrier back up again. So you literally have all of these holes in your attic wherever the vents come through, and the vapor barrier isn't sealed, which means all that cold air and all that hot air is leaching through into your house, causing mold, and it's just, it seems like a good idea, but it's a terrible idea. Nope.
Sorry.
No, it's okay. It's okay. It's okay.
Okay, yeah, that answers the questions, because I know it's for homes that the bedrooms might be further apart, like one bedroom where you put a heat pump is at one end of the hall and then you have other bedrooms at the other end of the hall. It's just been a conversation I've had different times with buyers looking at the attic systems.
When we've, you know, people look at the attic systems because they'd want to try and service every room. When we've compared the pricing to do an attic mounted system with all the ducting, the labor, and all that has to go along with it, versus putting an individual wall unit on the wall, it's the same price. You're not saving any more money. And the thing that the reason, you know, one of the reasons why we like doing an individual wall unit in each room is you get individual room control. So you can go, oh, go ahead.
So you're saying the price difference to do 3 heads upstairs, like if you had 3 bedrooms, for example, so 3 heads versus an attic system
unit, same
would
price.
be the same price. Wow.
Yeah, and in a lot of cases, like normally for us to do a 3-head system up in like on a top floor, the going price is about 9 to 10 grand plus tax. If you did an attic mounted system to try and service 3 bedrooms, you're looking at about the same amount of money, if not more. And the wall mounted units are they qualify for rebates through Efficiency Nova Scotia. The ones in the attic don't, which a lot of people are not told up front when they do their sales consult. Like I said, you have individual room control, because if anybody, you know, I think everybody here is known by now that you have a remote control that controls each wall unit. You can set the temperature, each room can be a different temperature, et cetera, et cetera. When you have an individually mounted attic unit, you have one thermostat ends up being in the hallway, or the master bedroom is usually where people put it. So that means that the other rooms, when you close the doors or whatever you're going to do, you have little to no control over what the temperature is going to be in those rooms.
Right.
Yeah.
Okay. Thank you.
Can I switch gears?
Yep.
Can you speak more to geothermal heating systems?
Sure.
Just basically how it works and the cost, and how much does it add value to a home, in your opinion?
So geothermal, I have geothermal in my house, and I have in-floor heating geothermal. I like it. I'm not an overly huge fan of in-floor heating, but that's regardless of geothermal. Um, Geothermal is an expensive upfront capital cost. If you took a 4,000 square foot home and you wanted to convert from, say, a forced air ducted furnace, oil furnace, to a geothermal heat pump furnace, you would probably be looking at the better part of $30,000 to $40,000 to do that. When someone has a home that is, 6,000 square foot plus, that's when we really start to look at those numbers and go, okay, these people are spending $7,000 to $10,000 a year to heat their home. So dumping $30,000 to $40,000, into converting to a geothermal heating system is probably going to save them about 85% of their heating costs. So that means that they'll pay that system back within a 6 to 7 year period. Whereas, if you have a lot of the middle income homes, the three to, well, probably the 2,500 to 4,000 square foot homes, in my opinion, and from what we've seen, it's the return on investment just isn't there. It's a nice system. And for those who, strictly want to be green and they don't care about the operating costs or savings or whatever, that's one thing. But for most people, it's always dollars and cents. And so with geothermal, what we see is that if someone has a home and you're 6,000 square feet plus, that's where that's where it's at for geothermal. Basically what has to happen in Halifax is, because we are basically on a giant rock and there's no dirt, most of the geothermal holes for the piping and everything have to be drilled vertically into the ground. So what they do is they bring a well driller in and they drill a 6-inch round hole in the ground. Sometimes there's 2 or 3 holes depending on the size of the system. Those holes can go down in the ground 600-700 feet below the surface, and they run piping and they fill it up with sand and all kinds of stuff. So that's where the big cost comes in, is because in order to get those holes in the ground and get the piping ran down and get that into the house, just that cost alone is, in the vicinity of $13,000 to $20,000 part of the system. And then you've got your equipment on the inside and your conversion from oil and all that sort of thing, which adds the other portion of the cost. So like I said, for customers who are, 6,000 square foot plus, it's a really, 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 really good idea. For those that are the 5,000 square foot home or less, I don't think the return on investment is there for those folks, because the amount of savings you're going to get year over year, it's going to take them 25 years to pay off the system. And by that point or before, they're going to be into a new system and they're going to have to refinance that. So like we have some clients that have geothermal, like some of them, the houses are 12,000 square feet. And if they had, if they didn't have geothermal, they would be spending upwards of $20,000 a year more on heating costs over geothermal. So the geothermal it's definitely the top tier of anything you could go for, but it's also one of the more pricey options, right?
Would you happen to know roughly what the return on investment is for that? Like if we were to do a comparative market analysis for a home that is 10,000 square feet, I hope one day I'll have one, but but I don't. But I mean, like there's some percentage, like roof, you get 106% return on investment. Do you know roughly what a geothermal system would?
I don't have that number. I can work something out and send it to you or whatever, so you have an exact figure or a good ballpark figure. I mean, normally we don't, in our industry, what we do for customers is we have an operating cost calculation. So what we can do is we have a program that we can put in all the existing equipment, and it'll tell you your base annual costs. And then we can put in a geothermal system or an air source regular heat pump or a gas furnace. We can put in different heating options. And then what it'll do is it'll give us an operating cost calculation. I would say, yeah, it's a good tool to use. And that's why I say that, most of the houses and most of the clients that we see, because you have to look at it all. You have to look at capital costs up front. if you're really crunching the numbers and you really want to know what it is, you've got to take into consideration your finance charge for that piece of equipment. You have to take into consideration maintenance fees and all those sorts of things to really try and get it knocked down to really what it is. But normally, when people convert from an existing, say whether it's an oil in-floor heating system, and let's say they spend $10,000 a year on oil, if they were to convert to geothermal, it would probably go down to $2,000 a year or less. Yeah, it's a significant drop, because the ground temperature below, like once you go down to about below 6 feet in the ground, especially where here in Nova Scotia, we're in bedrock, the ground temperature stays consistent all year long. It doesn't change like the air temperature does. So even if it's minus 25 outside, if you go 8 feet into the ground, the temperature is 45 degrees Fahrenheit, and it never changes. So we're drawing heat from the ground and converting that into the house, whereas with a typical heat pump, we're drawing heat from the air outside. And as the air outside temperature drops, so does the efficiency of the heat pump, because it can't absorb as much heat as it could if it was +5. That's where the geothermal really comes into play, is in that cold, you're still getting the same, right? And so, yeah, your operating costs go up because it's colder outside, but the medium in which you're getting your heat source from never changes course. And so that's where it really kicks in. We have, like, I think we were on a job a few months ago, and it was a 9,000 square foot home in Chester, and they have geothermal, and we installed it several years ago. And I kid you not, I'm pretty sure their total electrical bill for the year, including hot water, lights, and everything, is under $3,000 for that home.
Wow.
Yeah, it's significant.
You're
Because
going to have us all converting to geothermal.
Yeah, right. Come on. Have everybody with their $40,000 just throwing it away.
So do you see an increase in demand for geothermal?
There's not actually. There's a decreased demand for geothermal, because when I stopped working for the company I was working for and started Atmosphere, I was at a home show. I'll never forget when I started. I was at a home show, and I swear to God, there was 30 people in the lineup at the home show to speak to me about geothermal. And that year alone, we installed 17 systems. And since that time, I think we might install on average one every 18 months.
So the increase in demand of heat pumps?
I think the biggest reason that it shifted was because back then, that's like when I started, it was right when we all went from 60 cents a liter gas to $1.50. And of course, that was the big scare. So at that point in time, everyone was just dying to get away from oil. And so there was a big influx of interest, and people spent the money, and that's kind of what happened. The other thing with it is that the regular heat pump market, and not the mini splits so much, but the ducted, like the bigger systems, they've come quite a distance in the last 10 years. Like currently right now, we're a Carrier dealer. That's the primary brand that we sell. Carrier has the most efficient products on the market. And one of the products they have is a very top tier air source heat pump. And an air source heat pump, for anybody that doesn't know, is it draws heat from the air outside. So air source is the term of probably every heat pump you've seen other than geothermal. That particular model, if you would live in a climate like we live, where the temperature really doesn't go much below -5 most of the time, that heat pump almost has the same efficiency ratio as a geothermal heat pump.
Has the same efficiency as the geothermal?
Right, because what happens is that as the outside temperature drops, that's where your efficiency rating of your regular heat pump starts to diminish. And so at a certain point, a geothermal heat pump and a more elite air source heat pump will actually intersect. And so where we live in such a mild climate, that's why we say, again, like with the climate we live in, unless you're living in a large home, and a good high-end regular heat pump is probably going to be just as good for you as a geothermal would be, and you're going to spend about $15,000 to $20,000 less.
Right, makes sense.
Yeah.
So Joanne
all,
posted a question on the side. She said, if a buyer has a system in their new home, such as an ETS, and have no experience or knowledge, where is the best place to go for help?
it depends on the product. I think that if it's, for instance, if it is ETS, Nova Scotia Power would probably give a lot of advice for that. The other thing that they could do is search for what we normally do, tell customers when they call us, if it's a product that we don't necessarily service or know a lot about, we would recommend that the customer try to find a dealer for the particular brand of product they have. And that's probably the best approach. If someone, for instance, like I said, if you buy a Ford, then you automatically know that if you want information on your Ford, you're going to call a Ford dealer. So what we try to recommend to customers with their product is, if they have a brand of product that they have, regardless of whatever the product might be, the best course of action, I believe, is to just try and do a quick Google search or contact the manufacturer of the specific product and ask who the dealer is within the area, because the dealer of that product is probably going to have more knowledge, in most cases, is probably going to have more knowledge about that product than anyone else.
Okay, thank you. Does that answer your question, Joanne?
Yes, thank you.
Okay. Marianne, you have a question about in-floor heat.
I do. I'm in an older home, Corey, with it's a balloon frame.
Okay.
Really old home.
Okay.
120, 130 years old. My kitchen is really cold. A piece we built on the house, we put in-floor heating in, hot water in-floor heating. The existing kitchen, I don't want to raise the floor to put in-floor heating in, but my basement is open. Can you run, if I take the radiator out, use the same line, can I run in-floor heating through my joists in the basement to heat my kitchen floor?
Is the basement space heated or unheated?
Unheated.
Unheated.
And fairly cold.
You could, but in order to do that, what we do when we run heating pipes that have fluid in them for in-floor or anything, if you're going to do that, you can do that, but you have to put like an antifreeze solution in your system. So some homes, it used to be a requirement years ago, but it's no longer a requirement. For instance, at my home, I have in-floor heating. I have in-floor heating in my garage. Now, if I don't use the heating in my garage, theoretically, the garage can get just as cold as it is outside, and I run the risk of freezing the pipes, which obviously is what the issue would be here for you. So what normally will happen is that you can do it, but what you want to do is you want to have someone drain some of the water out of your system and make it so it has an antifreeze solution. So instead of just circulating water within your in-floor pipes, you would have water mixed in with like an antifreeze solution. So that way, when you're not heating and you turn the system off or whatever, if there's no water flow in those pipes, they won't freeze, because if they, obviously if they freeze, that you're going to be in a world of trouble, right? So if those pipes are running through an unheated space, it could be done, but you would have to have your system filled up with it's called a glycol, is a common one that they use. And there's a few other products now in the market that you can use, where if you fill up your system with part water, part antifreeze solution, then you'll reduce the risk of having pipes freeze. And that's just a calculation that whoever would do that for you should know how to calculate the mixture. Obviously, the more antifreeze solution to water solution, the colder the temperature can be. So for Nova Scotia,
my basement is not freezing, it's just not heated.
Right.
So if I am going down to the basement to do some work, I'll put a sweater on, but it's
Right.
not freezing.
If the basement is above zero and it's consistently above zero, and there's no risk of it really going below zero for an extended period of time, then I don't see there's an issue with that. I think that you could insulate the pipes, and that would probably work for you.
So how efficient, Corey, do you think that would be, being below the floor, below the existing floor, whatever that is? When I get down there, I'm assuming it's plywood or something. I don't know what they used 120 years ago. So,
what are you using for to heat the water? Is it
oil furnace?
Oil furnace. Well, it's obviously not going to be as efficient as if it's on top of the floor with your flooring over top, because you would have to run the piping in the joist space as close to the underside of the whatever it is, the plywood or whatever you have there. Normally, when we have people do that, we'll run the piping as close to the underside of the floor as we can. Then we'll put some insulation up inside the cavity, and then there's a foil material that we staple on, so it keeps as much heat up into the floor space. I don't think it's that terribly inefficient. For something like that, it's probably still going to be more cost effective than having electric baseboards in your kitchen.
So what would be the efficiency as opposed to running an electric pad underneath for in-floor heat?
Electric heat is expensive. The problem with it is that it's hard to dictate that without seeing the boiler. The big part of it is it depends on the boiler efficiency of your existing oil boiler, because some boilers are 96% efficient. So that means for every dollar of oil you put into it, you're getting 96 cents worth of energy out of it. Electric heat is
it's a new furnace.
newer one.
Yeah, 2 years old.
It would still be based, if you compare the price of oil, because that's a crapshoot in all of this, is anybody else noticed this morning or the other day, I noticed that the price of gas has gone up, I'm pretty sure 30 cents a liter in the last month and a half. So the problem with it is that as the price of oil goes up, it becomes, it's a crapshoot, because with electric, you've got a pretty steady cost, and it always goes up. But with oil today, it's 82 cents a liter, and by next week it could be $1.10. So if it were me and I was doing it, I would probably put the electric mat in versus going to the extent of running the piping and everything and extending off of the boiler, because the price of oil is so unstable that this year you might be ahead and next year you might be significantly behind if the price of oil goes to $1.10 or $1.20 a liter.
And if I put the electric mat in, am I limited the same way as I am with the coils, the water coils, as to what kind of flooring I can put on top? I know I was told I couldn't put hardwood, but I could put engineered hardwood.
You can put
ceramic or vinyl.
Right. So with electric mat, you can do ceramic, you can do vinyl, you can do laminate. I think the only thing that you might want to avoid even with in-floor heating is you don't want to get into doing too thick of hardwood flooring, because what's going to happen is the hardwood flooring is going to absorb most of the heat, and you're not going to get the heat in the space. So the floor, what ends up happening, what people realize is the floor stays nice and toasty warm on your feet, but there's not enough heat that ends up getting into the space in order to keep the space warm, because we're trying to do two things, right? We're trying to warm the floor because you get toasty toes, but then you also want to try and make sure you have enough heat actually resonating into the space in order to actually heat the kitchen itself, instead of just the floor. And that's where they get pretty fickle when it comes to the type of flooring you're going to lay down, right? I mean, if you're going to do hot water piping underneath, you don't want to have a whole bunch of layers above that. And if it's an older home, you may end up, if you haven't looked into it, I've seen older homes that have had 3/4 inch plywood planks. Then on top of that, they've had an underlay. Then on top of that, they've had an old, disgusting vinyl floor. Then on top of that, they put another underlay. And then on top of that, there's ceramic tiles. So if you can actually get the floor down to, bare level, then you can pretty much go any direction you want, as long as what you put over top of it isn't too thick.
Okay, my last question concerning that. No matter which way I go, would you go under the kitchen cupboards?
It's funny you mentioned that.
I'm renovating, so.
I would not, actually. And the reason why is because I personally, like I said, I have in-floor heating. And I brought this up to our secretary this morning. I noticed that I put my potatoes and my onions and a few other odds and sods in my cupboards. And I couldn't figure out for the life of me why my potatoes wouldn't last any more than 3 or 4 days, and why my onions kept going bad, or why so this morning I got up, and because it was cold this morning, the in-floor heating's cooking right along. So the floor is nice and warm. So I opened the cupboard door, and my son was there with me, and he took out the bread loaf, and the whole bag of bread was sweating. And I'm like, why is the bread sweating? Well, the bread was sweating because all of the heat from the in-floor is resonating up through the cabinets and heating everything up inside the cabinets. So it is in my opinion that I would not put the in-floor heating underneath the cabinetry, because it's going to, especially on a day like today, where you have a high heating demand in the kitchen, if you're really, really heating that space, you're putting a lot of heat in that cupboard and it's spoiling your food. If you're putting, canned goods and those sorts of things. I never, ever, ever thought of this before. And today, it was funny you mentioned that, because today it was actually the day where I was like, oh, I finally realized why my potatoes won't last. So.
Okay, thank you.
No
Yep.
problem. Any other questions?
That's been very thorough.
Yeah.
Thank you, Corey.
No worries. No worries.
I have one last question from a real estate point of view. I recall a conversation where we're trying to figure out, what can we do to save, I don't know, hassle for our clients when it comes to looking at properties. Like, are you aware of any red flags or anything, any indicators that we could be aware of that may be, a deal killer for our clients? And I guess what I'm trying to say is, before offering on a property, and spending money on a home inspection, is there things that we could be aware of that would prepare our clients when looking at heating systems?
Well, I know that I think a big part of looking at purchasing a home, and you guys would know better than me, but a big part of that, I think, before someone even decides to put an offer on the property, one of the things that should be disclosed is 2 years, not a year, but 2 years worth of electrical bills and oil bills, if they have oil or gas or whatever it is. Because from a heating perspective, I know that for a lot of times when you look at buying a home, people look at it and they're like, okay, well, I want to look at your last 6 months of your power bill, or you want to look at your oil bills or whatever. What I can do when we follow up here is because I've been going through this with everyone, I'm thinking of some ideas that would be very helpful for you guys. One of the things that would be good is to take a rule of thumb, say per 1,000 square feet of home, and it really doesn't matter whether it's electric heat or oil or heat pump or whatever. There's an acceptable and expected operating costs, right? I mean, you've got variables like, where the previous tenants 80-year-olds who like the temperature 25 degrees, or were they the opposite and they kept the host at 15? We have those people, but there is a range, an acceptable range, and that is a red flag in itself, because we have a lot of customers that call and they say, we bought this house, it's 3,200 square feet, and it costs us, I think we had one a couple of months ago, no word of a lie, their heating bill was like $2,000 every 2 months. And it was only just a regular small home. So of course they bought the home and it was beyond their threshold of, having any repercussion or anything like that, or legal recourse. So we ended up going and having a look. Well, it turned out that the electric heater that was in the heat pump was faulty, and it had been faulty for quite some time. So we replaced it. So I guess to kind of answer the question is, I think the biggest outlier is the average operating costs for the existing homeowner for not a 1 year period, but for a 2 year period. And I say 2 years because it gives us some really good data. What it does is it tells us, okay, you know what, year one was XYZ, year two was XYZ. If they're relatively comparable and they're within the threshold of acceptable, then you know what, that's acceptable. There shouldn't be any red flag there for the heating system to be inappropriate. But 9 times out of 10, the biggest issue is operating costs. And when you have high operating costs in a heating system, that's when the red flags start going off, because you have to ask yourself, why? And we have people call us, like I said at the beginning of this conversation, where everyone's so hot and excited about the heat pumps, they get into a home that's 3,000 square feet and they expect to have this great power bill for their heating costs, and it turns out that it's higher than electric baseboard heating. You know, those are the sorts of things that we look at. And because as far as a real estate agent goes, going in and just, you know, eyeballing a heat pump inside or outside of a home, you guys are never going to know. You're just never going to know. You won't know what is right and what's wrong. Even a home inspector doesn't. And we've actually, it's funny, we've actually been thinking about starting a separate division of our company called the heat pump inspector that people can call for $130 or something like that, or real estate agents can call on for somebody like myself or a licensed actual technician that knows the ins and outs of heat pumps specifically, because that seems to be the biggest issue, to be able to go and inspect them and say things, you know, like the ductwork's too small, the heat pump's too big, the heat pump's too small, you know, the heat pump's in the attic, you know, and actually go through it and say, you know, this is what's wrong with this heating system. And if I were you, I would barter this out of the deal, or I would walk away from the home altogether. But what I can do, like I said, when we follow up, I'd probably need a week or so to put it together. I think what we can do is give you guys like a little bit of a cut sheet, which I was thinking about today, just some little checklists that you can go through even in your own mind, to be able to go, okay, yeah, you know, like you know, for this 3,000 square foot home that's 15 years old with a heat pump, you know, normally the total electrical consumption should be around here, and it just so turns out that it's $1,500 more than it should be. So maybe we should have somebody actually come and inspect this system and actually give us their take on it, right? So because it's honestly pretty difficult for a real estate agent to be able to red flag that kind of stuff. But I know it's one of the biggest problems. It's some of the bigger problems with the houses when people buy them is, you know, rot and rotten wood and things, because people cover things up, and poorly installed heating systems. And unfortunately, like I said before, we're living through a time right now where skilled labor is at an all-time low, but at an all-time high demand. So I don't even know if you could call some of these people that are out there installing stuff, and I'm not talking just heating systems, skilled at all. So, you know, I've seen brand new homes in Bedford West, and I wouldn't live in that house myself, because of some of the things that have gone on. You know, we have to remember that a lot of these building contractors, just like us, you know, I'm in business to make money. You guys are in business to sell homes and make money. We're all in business to make money, but there's other people that are in business to make money at such a level, it's at everyone's expense. And I think that's inappropriate. And I think that we have to try and all work together to cleanse, you know, our industries of those kinds of people, because they're the ones that drag us all down. So I guess in a long-winded way, there isn't really any way for you guys to red flag something other than being able to look at a power bill, or call on somebody like myself or another heating expert to say, hey, you know what? I've got a client looking at buying this house. We've got some questions about the heating system. You know, this is the information I have. It's XYZ years old. This is kind of the insulation values, you know, and give us a little bit of meat and potatoes as to the way the home's constructed and what it has. And then we can say, you know what, based on what we know, it should cost about this much money a year to run the heating system in that home. And then if you as a real estate agent go back to the owner and say, okay, we'd like to see some oil bills, or we'd like to see some power bills, or whatever, and it turns out that the numbers are double that, then it's a red flag. And then you can look at it and go, okay, yeah, you know what, either we might want to walk away from this one, or we might at least want to spend, you know, $100 or whatever it is to have somebody professional that knows what they're doing to come over and actually go through it and tell us, is this normal, or is there actually something wrong with this system, right?
Valuable. That's very valuable. Thank you for that.
So I don't want to break up this amazing conversation, but we're going to get bumped off here in a couple of minutes. There's another Zoom meeting scheduled for 2. So Corey, this has been amazing. It's been fantastic. The information has just been excellent. And I know, because we're recording it, I know there's going to be a number of agents watching it from our YouTube channel as well. So is Is it something that you're able to get out to us, the checklist that you have?
Yeah,
Or
for
that you're going
sure.
to do up?
Yeah, what I'm going to do is just give me a week or so to put something together, because I've been taking some notes here, speaking with everyone, and I had some ideas here previous, just as because we do get a lot of calls from real estate agents. So
Mhm.
in order to give you guys just a checklist that you can go in and go, okay, what am I looking for? Does it have this? Does it have this? Does it have this? Et cetera, et cetera. And then that way it loads you with information. And then at any point, if you want to go further with that, you can call on myself or, like I said, another heating expert, whatever the case may be. And they should be able to take that information and at least give you some pretty concrete numbers and some good guidance as to the direction you're going, right?
That would be fantastic.
Yep, we can do that for sure.
Fantastic.
One last quick question.
Sorry if I could, and if we actually did want somebody to inspect the house for us, would that be available through your company and at what cost?
Yes, we could probably do that. Like I said, we've been toying around with the idea of this heat pump inspector idea. So, I would say it's probably going to be like, between 100 and 150 bucks with tax kind of thing, for somebody to come. We probably take an hour or so and go through the home, get all the information, and write up a legitimate report. So that way you have something to use. Because ultimately, the biggest thing here is dotting your I's and crossing your T's. No one wants any legal stuff coming back at them and all that sort of thing. So, but yeah, like I would say probably, if you allowed for 150 bucks for us to come over, it would take about an hour or so time to inspect the system, go through everything, make sure it's all good, red flag anything that, is wear and tear or, if we see something dramatic or those sorts of things, because we do run into this a lot. So.
Yeah.
Yeah.
One quick last question, can I? Corey, I'm in beautiful Cape Breton, not in Halifax.
Okay.
So my personal question about my in-floor heat, where do I begin with that? Do I begin with a contractor? Do I begin with a furnace guy? Do I begin with?
So if you're going to go if I were you, I would price it both ways, and then you could weigh your pros and cons. So if you're going to do the electric mat in the floor, that's an electrician. Okay. And if you're going to go with extending off of your current oil boiler, that would be a plumbing and heating company or a plumber. Okay. And if I were you, I would probably get both to come. They should offer free estimates. Most of us do. And then they can go through with you, and then they can offer you a legitimate concrete quote. The electrical contractor may have to look at your panel and say it may not even work for your existing panel. So, that way, at least it gives you all the ins and outs of what you're doing. And then, then you can make an educated decision by having all the information.
Mm-hmm. Thank you.
Can I just comment there? Corey, you said before about that insulating factor. I know most in-floor heating systems work best when there's a flooring above it that conducts heat. And in an old house, like Marianne says she has, if you've got an inch to an inch and a half, inch and 3/4 of wood between that heating source underneath and finally getting up to the floor surface, your thermostat's not going to be working properly because you've got an insulator in between the two.
Right. We mentioned that earlier in the conversation. We talked about the floor thickness and how you can't have too much of a thickness on the floor. Otherwise, you're not going to get any heat above the floor, and it's just going to keep the floor warm versus heating the actual space.
Yeah, I just wanted to raise that again. So, Marianne, that's one of the key things you want to look at is that insulating factor below. Your heat's going to have a hard time getting up to the floor surface.
Right, and that's where the plumbing and heating expert that comes to look should be able to provide that information to her. Because if we were to look at that project, those are the things that we would look at. And if we did that, then we would tell you right from the get-go, either this will work or it won't work. And it just depends on how many layers are on top of your floor. If there's too many layers on top of the floor, then you're not going to get enough heat through the floor to heat the space, at which point it may be more advantageous to go to an electric mat that's on top of the floor versus putting the in-floor heating underneath.
Mm-hmm. Anyway, we got to start another meeting with the account, so we'll have to either maybe do this again in a month or two.
Yeah, no problem. You guys can
Right.
reach out anytime and I'll put a checklist together and I'll get in touch with Tina when I have everything ready.
Greatly
Perfect.
appreciated. Thank you, Corey.
Okay, guys,
All
take
right,
care. Have a
thanks,
good
man.
day.
Yeah,
All right,
thanks a
bye-bye.
lot,
Bye-bye.
Corey. That was a great